actually very critical. This is also something that you kind of know inside and out. You would not believe how many people actually don't have a good grasp of scope, and so when they write functions or when they use variables, things just break and they have no idea why. Can everyone see my screen now? It should say scope. Just shout if you don't. Okay, awesome. So scope. So one concept, just scope, but a fairly complex concept. Okay, so the analogy I always give with scope is you can think of it as like a sandbox, right? Remember how like, when you're younger, you were at the playground or the park, and you have a sandbox, and essentially that sandbox is kind of like your domain, right? Like the things in that sandbox are yours, and you can use and play with and do whatever you want, and the things outside the sandbox like are not yours, right? So you don't have rights or access to it. Scope is pretty much in the same way. Scope pretty much operates in the same way, except now what defines our sandbox is actually our old friend, the curly braces. Remember how earlier when we were first talking about indentation, I mentioned, oh yeah, like there's a curly brace. The curly braces tell you that you're in one block of code. Well, that block actually means something, right? It's not just like a nice spacing or decoration. It actually means you're creating a scope. You're creating a sandbox. And the power of that block basically says is, or the power of that scope says, hey, this scope is like the perimeter of your sandbox. This scope tells you what variables you have access to, which is everything inside that block, and what you don't have access to, which is everything outside of that block, right? So that's fundamentally what scope is. It's just the limits around your code that tells you which variables you can access at a given place in your code. So let's take a look at an example. On line 4, I have a variable called wow. I console log it out. I log out wow. Nothing really, crazy is happening here, right? But something else that is a little bit tricky, and this is something that we discovered yesterday. It actually was if you create a variable and you don't actually create a value for it. What happens is you actually get back undefined. And so this is something that I'll talk through for now, but then I'll come back to at the very end of the lecture to explain why this is. So on line 7, you see us create this variable called wait for it. And we console log it out on line 5, and we console log out on line 9. But when we do that, we notice how in console log out and console log on line 5, we see wait for it is actually undefined. And then on line 9, we get back here I am. Now, the big question here is, well, on line 5, I understand why on line 9, wait for it is here I am, clearly I defined on line 7. But on line 5, the bigger question is, why is that not an error, right? Like, why is it undefined even? So all of this is related to this idea of scope and kind of where and when we can access certain variables. Okay, so to kind of put us on a more pragmatic route here, functional scope. This is just a really fancy way of saying the curly braces around your function. One really big change in newer versions of JavaScript is if you look at not really old code, but decently old JavaScript code, you'll notice people created variables with the var keyword, right? They do like var x equals 6. Okay. Nowadays, you'll probably notice people not really using var anymore, and you'll see them using the word let, right? And so we'll talk about why let is kind of the newer, more popular way to create variables. But for now, let's just say that on line 6 there, in this happy function, I'm creating a variable called message, and I do it with let message equals I am so happy. Okay. When I console log out message here, I get back I am so happy. But if on line 11 I try to console log out message again, I get back a reference error. And if you recall yesterday when we did our thing on debugging, what is a reference error? A reference error basically says, hey, you're trying to use a variable that doesn't exist. And so this kind of brings us to one of the very, very key fundamental aspects of functional scope, which is basically saying variables you create inside of a function can be read by everyone inside the function. But as soon as you leave the function, no one else has access to those variables. Okay, so if I go back to my sandbox example, like if I'm in my sandbox and I have a toy truck in there, like I can play with my toy truck, and anyone in my sandbox can play with my toy truck. someone from the outside of my sandbox can't reach in and play with my toy truck, right? Like that's the principle, right? Like that's why I had these boundaries here. And the same thing applies here. On line 6, I create a message called, I create a variable called message. It's inside my happy function scope, right? It's inside that scope that's defined by the open curly brace on line 5 and ended by the closing curly brace on line 8. Like that exists inside that scope. On line 11, I left my function, right? I'm outside. I'm after the closing curly brace on line 8. I'm out of my happy function. This means no one else can look inside my scope, inside my happy function, and try to figure out what variables we have inside there. Okay, so scope means you cannot access variables that are defined in a given function scope outside of that function scope. Right, so anyone inside can access it. Line 7 can access it. Line 11 cannot, because after line 8 we leave that function scope. Similarly, what if we have an instance in which we have almost like a collision or an overwrite, right? On line 3, I create a variable called message. On line 5, I create a variable called on line 6, on line 5, I create a function called log a message. And on line 6, I actually create another variable called message. And on line 9, I console log out message. The question now becomes, okay, so on line 9, which message am I gonna print out? And the answer is and this probably helps if you visually put yourself as like the computer again. Like when a computer reads a variable, what it will do is it will look in its own scope for the value that's closest to it, right? That's like physically closest to it. And so on line 9, when the computer is looking for the variable message, it will say, okay, great, I need to find a variable called message. Let me look in my own scope first. Let me look in my own sandbox first. And when it looks in the log a message scope, it says, oh, great, on line 6, I have a variable called message. And that's what you use, right? And that's pretty much it. Like at that point, JavaScript doesn't keep looking. It's like, well, I need a variable called message, and I found a variable called message, so I'm good, right? I can use that. And so this is another principle of JavaScript, which is that when you have an instance in which you have multiple variables with the same name, what JavaScript does is it will look for the variable that's physically closest to it, that's in the closest scope. So if we do another example here, this code looks exactly identical to the previous one, except now on line 6, rather than calling a message, we call it MSG. Okay. Now on line 10, when we console log out message, JavaScript's going to do the same thing it does before. It's going to say, great, let me look in my own scope for this variable called message, and it can't find it, right? It found an MSG, but that doesn't matter. It's looking for the variable called message. So if JavaScript cannot find the variable inside the local scope, then it will look to see it's what we call the parent scope, or the scope outside of it, right? And in this case, if we leave the log a message function, I'm now kind of on the global scope, right? I'm on like the main page, and there JavaScript's gonna say, let me look for a variable called message. Do I find it? Oh yeah, I do. It's on line 3 there. It's called think globally. And so therefore, when I console log it out, I console log out think globally. And so this is a second kind of really big tenet of scope, which is that with scope, you cannot look inside someone else's scope, but you're able to look inside your scope. You're also able to look inside any scope that you're a part of, that you're in, what we call the parent scope, right? So in this case, for this log a message function, when we try to look for message, we looked in our own local scope first, which is the scope of log a message, and we couldn't find it. So then we went to our parent scope, the outer scope, and the outer scope in this case is a global scope. It's like the main page that everything is on, and we were able to find message. And this applies not just to, and I think someone yesterday actually made a point about this, right? Whenever we create a parameter, like in this case, notice how on line 5 in the log a message function, we're passing in message. Well, that message, that's a variable, and that's a variable that exists inside the log a message function scope, right? So on line 6, when I console log out message, I get act locally. Why? Because on line 9, where I invoke log a message, notice how I'm passing in this string act locally. On line 5, notice how then on line 5, message becomes act locally, And so on line 6, when console logout message, well, the JavaScript's gonna say, great, let me look at my own scope first. Do I have a variable inside the logout message scope that's called message? Yeah, I do. Great, let's print it out. And the value of it is act locally. At this point, we never make it to line 3 because JavaScript says, I found a value that works for me that's closer than that one. So I don't even need to look past my local scope. And so this is why when we talk about naming variables, one of the reasons why we do this is also because one of the most useful parts of scope is also because it kind of helps us prevent these collisions, right? It's almost like on line 3, that becomes like a default value. Like, hey, if no one else, like if you're trying to use a variable message and you don't have access to it, use this as like a backstop. Otherwise, use your own version of message. Okay, so that's pretty much like the heart of the scope. One analogy I always give, which I guess may work, may not work, is I think of like if we think of it in the context of kind of money, right? Like let's say you were running behind on payments or you need some money, right? You obviously, or not obviously, but you will look in your own bank account first for money, right? So that, in my opinion, would be like your local scope. Like that's your bank account. You're looking for money there. If that doesn't work, you would then say, okay, well, I can had to borrow money. Who would I borrow from? Well, in this analogy, you would say, okay, let me ask my parents for money, right? Like they would be the next people in line for me to borrow from. And so that would be like your parent scope, right? And then if that doesn't work, you can go to maybe your parents' parents, right? Your grandparents. So then that would be like your parents' parent scope. And we'll talk about what that looks like here as well. But essentially what you do is you kind of gradually look at your own scope first, then you look at the layer outside of it, then a layer outside of it, then a layer outside of it until you reach kind of the global scope, right? And just for your context, in JavaScript, if JavaScript looks for a variable, it can't find it in your local scope, it can't find it in your parent scope, and it keeps looking outer and outermost until it gets to the global scope, and if it still can't find it, well, to JavaScript, that's a reference error, right? That's when it throws that error. Now, the reason why I like that analogy is because if you need some money, typically speaking, you don't look in your kid's bank account and take money from there, right? Nor do you really look in your sibling's bank account and take money from there. And so it kind of highlights a relationship here where in JavaScript, at least for scope, you always want to start with your own scope first and then move outwards to your parents and grandparents and etc. But you don't look in your what we call the sibling scopes, and you don't look inside your child scopes. So any functions inside of it. So let's take a look at like kind of how that relationship works, in the real world, right? So on line 2, we have a variable called global var. On line 5, we have a function, or sorry, line 4, we have a function called outer. And in there, on line 5, we define a variable called outer var. And then inside the outer function, on line 7, we have another function called inner. And inside the inner function, we define this variable called inner var, and we set it equal to inner. Now, on line 9, we console log out global var, outer var, inner var. On line 11, we invoke inner, and on line 14, we invoke outer. Okay, so if I walk through this code, what's happening is I go to line 2, I create a variable. On line 4 through 12, I define a function, but I don't run it just yet. And on line 14 is when I actually run the outer function. So after I execute line 14, that takes me into line 5 because now I'm actually running this function. On line 5, I create a variable called outer var, and on line 7 through 10, I create a function called inner, but I'm not invoking it just yet. I actually invoke it on line 11, right? And so when I invoke it on line 11, then that takes me into line 8, which I created a variable called inner var. And on line 9, I console log out global var, outer var, inner var. So when I console log out global var, the first thing that I would do is I would look in my own local scope, right? In this case, this console log occurs in the inner function. So whenever I say local scope, I'm basically talking about lines 7 through 10. That's the inner scope, inner function. That's the local scope that we're talking about, okay? So if we look in our local scope for this variable called global var, do we have it? No, nothing between lines 7 through 10 says global var. So we say, okay, great. Well, maybe our parent scope has it. Well, what's our parent scope of the inner function? Well, the inner function is placed inside, and if now we zoom out, we see, oh, it's trapped inside the scope of the outer function between lines 4 through 12. And so at that point we say, great, is there a variable called global var in the outer function scope? And when we look through 4 through 12, we say, nope, nothing still. So lastly, we say, okay, let's look at the parent of the outer function, right? Well, there's no quote unquote parent anymore. It's just the global scope, right? It's just like the master scope, like the default window that everything's printing on. And so when we look through lines 1 through 14, we ask, is there a variable called global var? And we say, oh yeah, cool. On line 2, there's a variable called global, or called global var, and the value of it is global. And so that's the value that we print out there on line 9 for global var. We do the similar process for outer var. We look in our local scope for outer var. Does a variable exist between lines 7 through 10? Nope, it doesn't exist. So then we look to our parent scope between lines 4 through 12. Does the outer var exist? Oh yeah, it does, right there on line 5. So great. So that's what we use. That's what we print out. And then lastly, for inner var, we're trying to print out whatever the value of inner var is. We look in our local scope. Do we have a variable called inner var between lines 7 through 10? Yep, we do. Great. No need to look any further. We then print out that inner var value and we get back inner. And so scope is a highly logical thing, but it's also a very spatial thing. Like when you think about scope, like be very, very clear at given point when you're writing your code. Okay, what do I have access to at this given moment, right? Versus what do I not have access to? If I have another example here, on line 2, I created a variable called collision, and I set it equal to global. On line 14, on line 4 through 12, I define a function called outer. I don't execute it just yet, but on line 14, I actually execute the outer function, and I pass in this string called outer, right? When I go inside the outer function now, because I am executing it, you'll notice the outer function is expecting a parameter called collision. Well, the parameter collision is just whatever argument is being passed in. On line 14, I'm passing in this string called outer, and so by the time we get to line 5, there's another variable, a parameter or a variable called collision that's equal to outer. And so we go through line 6 through 9, in which we create a function. On line 11, we actually execute that function. And on line 7, we create another variable called collision, and now we set it equal to the string called inner. When we get to line 8, and we console log out collision, JavaScript's going to say, hey, I know there are multiple collisions on the page, but I'm going to look at this from a very, very sequential process, right? The first step of the process is, do I have a variable called collision in my inner scope between lines 6 through 9? And the answer is, yep, right there on line 7. So then at that point, JavaScript says, great, I found it. I don't care how many other versions of collision there are on the page. I use the one that's closest to me in my local scope, in which case that's inner. And so that's what's being printed out on line 8. Any questions so far? Everyone good?
Yeah.
Everyone still there?
Yeah, I'm here.
Cool.
Yeah, I think this is where I get hooked up on class systems or classes and trying to figure out what needs to go in a separate class later on.
Yeah.
Will be helpful in terms of.
Yep. So scope is one of the things that like it's especially when you're first learning it, it's super helpful to actually just talk through with your partner, like, okay, where am I and what scope am I in? Who are my parent scopes? Who are my parents' parent scopes? Who are my child scopes or sibling scopes or the scopes that I don't have access to, right? So those are all kind of the questions that you need to be aware of as you're writing code from here on out. Okay. So we also have a few other examples. This just is almost a mirror image of the previous example, except now between line 6 through 7, we don't create our own version of the collision variable anymore, right? So on line 7, when we console log out collision, we do the same thing we did before. We say, is there a variable called collision in between our local scope, between line 6 through 8? The answer is no. Great, so let's try to find in our parent scope. Is there a variable called collision in our parent scope between lines 4 through 10? Oh yeah, it is right there in the parameter that we create on line 4. Oh great, on line 4 we have a variable called collision, and what's the value of it? The value of it is outer, because that's what we passed into the function on line 12. And so when we console log out collision, that's the version of collision that we use. And then to wrap up this 3 set of slides, probably guess where the next one's going. If we don't define any version of collision anywhere else, on line 7, when I console log out collision, JavaScript will say, great, do you have a version of collision in your inner scope between lines 6 through 8? No, I don't. Does your parents have a version of the scope between lines 4 through 10? Nope. Do your parents' have it? Well, our parents is basically the global scope. And yep, on line 2 there, I see a variable called collision. So that's what I'm going to use. And once again, if line 2 didn't exist, if our global scope also didn't have a variable called collision, then JavaScript would say, hey, this is a reference error. You're trying to use a variable that does not exist. Okay. And so once again, this kind of this slide is actually, this example here actually kind of just re-emphasizes what we talked about earlier, how you have access to your own scope, your parents' scope, your parents' scope, but you don't have access to your kid's scope. Okay, so how do we prove this? Well, here we create a function on line 3 through 12 called outer, and on line 14 we execute outer, right? When we go inside outer, we see on line 4 there's a variable called outer var. On line 6 through 9, we create a function called inner. On line 10, we invoke inner, right? And when we invoke inner on line 7, we create this variable called inner var. On line 8, we console log out outer var, which is the outer var is going to come from the one on line 4, right? Because when we console log out outer var on line 8, JavaScript's going to say, great, is there an outer var between line 6 through 9? Nope. Do your parents have an outer var between lines 3 through 12? And we say, yep, right there on line 4. So that's what we use for outer var on line 8. And then for the inner var on line 8, we look at line 7 because that's the variable that exists in our local scope. So that part works perfectly fine, right? Like inner function can invoke properly. But when we get to line 11 and we say, oh, great, I also want to print out inner var. Once again, put yourself in the shoes of JavaScript, right? At that point, we're going to say, great. On line 11, we're looking for a variable called inner var. In your local scope, between lines 3 through 11, do you have a variable called inner var, provided you cannot look in the function of someone that you're not a child of, right? Like you can look in your function scope, you can look in your parents' function scope, but you cannot look in the scope of someone that's inside of you, right? So in this case, we would consider inner scope to be a child of this outer function scope. So if we pretend like everything between lines 6 through 9 is a black box, on line 11, when we look for inner var, we say, does our function scope have it between lines 4 through 6 and between lines 10 through 11? And we say, nope. Okay, do our parent scope have it? Or in this case, a global scope, does that have the inner var variable? And the answer is no. So when we do that, we're going to get back the first printout of outer inner, that comes from line 8. And then when we get to line 11, we hit this error. Reference error, inner var is not defined. And the reason why it's not defined is because inner var is defined in the scope of one of our child functions. And we cannot access the scope of functions that are inside of us, that are considered our children. We can only access our scope, our parent scope, etc., right? So think of the scope lookup process as it looks only in one direction, which is always outer, right? You're trying to get closer and closer to the window scope, or sorry, to the global scope, and you're never looking inside another scope. And this is a very similar example here. Yeah, so here the point of this is that on line 9 there, when we print out outer var, even though there's an outer var that exists on line 5, notice how we've now kind of very sneakily put in the outer var as a parameter on line 7, right? So on line 9, when we're trying to look for outer var, we use the outer var that's in our own local scope first, which is one on line 7. And curiously enough, notice how the outer var on line 7, that's going to take the value of whatever is being passed in when we call inner. But when we call inner on line 11, notice how we don't pass anything in. So what's the value of outer var at that point? At that point, the point of outer var is undefined, because that's basically us saying, hey, I'm going to create a value. I'm going to create a variable called outer var for you, but there's no there's no value just yet. So in that case, in JavaScript, if you create a variable but you don't give it a value just yet, then that variable will be undefined until you replace that with a actual value. Okay. So far we've talked mostly about function scopes, but if you remember, other kind of things also have these curly brace scopes as well, right? And so we call those kind of block scopes, right? And so here's where the importance of let versus var comes in. What var does is var used to or what var still does. When you use var to create a variable, like you do var x equals 6, that basically says, hey, everything inside my nearest function scope now has access to this variable called x. Okay. What let does differently is let says, well, I don't want to restrain myself to the function scope. I actually want to be more precise, and I want to restrain myself to the nearest scope, period, whether it be a block scope or a function scope. And so here on line 4, if you notice in this if statement that's going to execute because we say if true, we create a variable called block on line 5, and we set it equal to Jenny from thee. Okay. On line 6, if I console log out block, I get back Jenny from the block. On line 9, when I try to console log out block, I get a reference error. And the reason for that is quite simply because I am trying to create something here. Or sorry, on line 5, I created a variable called block that only, with the let keyword, that only exists within the nearest set of block scopes. And in this case, the nearest block scope is not a function or the window, it's this if statement, right? So block only exists within these set of curly braces, and as soon as I get outside of the curly braces, I no longer have access to the block variable. The difference is if I had used var instead, if I had done var Jenny from thee, well, hey, var puts this variable on the nearest function scope, right? In this case, the nearest function scope is actually the global scope. And so, because of that, I can access this block keyword outside of this if statement. Okay, and so the reason why people use let now is it's more restrictive, which we think is like, oh, like it's a bigger hassle to use, but actually in programming, we always want to err on the side of being more precise whenever possible rather than less precise. And so because of that, the reason why let is so popular is because when I see a let keyword, I can really quickly tell right away who and where has access to this variable. With var, I sometimes may need to look a little bit further or it's a little bit less clear. And by creating all of these scopes with these different variables, I also mitigate collision error, right? So if I use var here on line 4, well, somewhere else in this window, someone else could also use block, and it could actually override my value. If I use let, then I know for a fact that block only exists in between lines 3 through 6, and if anyone else tries to use it, they're not going to interfere with my value of block. And so that's the big reason why there's been a transition from var to let. It's just because let is a lot more precise and it's a lot more restrictive in terms of saying, hey, rather than now binding your variable to the nearest function, we're now binding it to the nearest set of curly braces, period. Any question there? Michael, do you have a question?
Yeah, sorry, very quickly. Could you just go back 2 slides? I just want to clarify this for me just one last time, and maybe for anyone else. Actually, one slide where you were talking about the let keyword.
Sure. Yeah.
Yeah. What kind of threw me before I did like some more research on it is on line 1, it kind of reads like any block of code inside of curly brackets. Would it be fair to say, more precise, to say any block of code that includes the keyword let inside of a pair of curly brackets or outside of a pair of curly brackets? Because you said it's nearest the let keyword near the nearest set of brackets, curly brackets. Because initially, like when I didn't understand this as clearly as I think I do now, I just thought that you throw in a var inside, and then you cover this in the next slide, but you throw in a var inside a curly bracket, and you're creating a scope of a block scope of some kind. But the second the let keyword is included, it's completely blocked out from 4 to 7. Does that make sense?
Yeah. So
it just reads a little bit like code inside of curly brackets.
So the scope is created by the curly brackets. Whether or not let or var is inside those curly brackets has no bearing, right? That scope is created regardless of whether or not what's inside of it.
Yep.
Okay. So the question now becomes, when you create a variable with let, then regardless of whether those curly braces are caused by an if statement like it is on this page, or if it's caused by a function declaration, when you use a let keyword to create a variable, that variable is only available between those set of curly braces. Okay. If you use a var keyword, then if the curly braces are caused by a if statement like it is on this page, then you can use that variable outside of the if statement. Whereas if that curly braces was caused by a function, then you can still then it would operate the same thing as a let, in the sense that you would still be able to access that variable only inside of that function. So the curly brackets create a scope every single time. The way to think about var versus let, it's just a matter of, hey, that variable that's created by var or let, where can I use it, right? If it's let, then it means I can only use it within the nearest set, within the set of curly braces, within the nearest set of curly braces to me. If it's var, it just means I can use that variable within the nearest set of curly braces that's created by a function.
Okay.
Are there any other questions on this from anyone? Like, this is pretty much the entire lesson. We have like a few other slides left, but like this is a crux of it. If you understand this, then the rest of this is going to be a lot easier. Right? This is just what scope is, right? Scope is basically this curly braces. It creates this perimeter, the sandbox around it. What we've talked so far is you can look in your own scope, and JavaScript will look in your own scope first. It will look in your parent scope and parent scope all the way up to the global scope, but you cannot look in the scope of a function that's inside of you or anyone that's adjacent to you. And then secondly, what we're talking about here is just saying, by the way, when you create variables inside these scopes, these variables exist depending on whether you use var versus let. They have different places where you can use them and access them, right? And by us, for now at least, by default, let is pretty much like the default way you should be using to create variables. It's just a lot more precise. And when you see let, then you know exactly, it's a lot more clear to you where you have access to that variable. So any questions on anything I just said there? Because that's what the majority of this workshop is going to be focusing on. Cool. All right. I'm just going to wrap it up here. In terms of the next few slides, it should be taking no more than 1 or 2 minutes. One of the last things we'll talk about here, and this is something that's actually not as important for you to know right now in terms of like this workshop or any necessarily even like the assessment, is just that whenever in JavaScript there's an order in which the page reads a code, and actually when JavaScript reads any page of code, it actually reads it twice. The first time it reads it, it actually just goes through and it just actually says, okay, this exists, this exists, this exists, this exists. The second time it reads it, it actually says, oh, this has a value. Oh, you want to run this. Oh, you want to do these things, right? And so this leads us to this concept called hoisting. Hoisting, just in plain English, right? It means to lift up, right? And when we talk about hoisting in programming, it just means the first time the computer goes through, the first time JavaScript goes through a block of code, it will actually take functions made using the function declaration, and it will hoist it up to the top of the page. And then the second time it goes through the page, it will execute all the code in order. So when I look at this page right here on the code that's on the page right now, notice how on line 4 I call will this work, and I invoke it before this function is created on line 6 through 8. And yet when I do invoke that function, it works perfectly. And so the rationale for this is just because when JavaScript first goes through the page, it will say, oh, on line 6 through 8, I have a function called, or rather, the first time JavaScript goes through the code, it will go to line 4 first, and it will say, oh, here's someone invoking a function. I'll do that on my second pass through. And then it gets to line 6 through and says, oh, here's a function that's being declared. Let me put this on the top of the page. And then on the second time it goes through the page, it'll say, oh, on line 4, let me execute this function. Oh, great, I see it already exists because during the first pass through, I hoisted up to the top of the page. And so that's why you're able, for functions, you're able to invoke them, assuming you declare with a function keyword. That's the reason why you're able to invoke them before before they're quote unquote created in terms of sequence on the page. So it's a little bit of a nuance, but this is also the reason why people see Gabriella's a bit confused. This is also the reason why people tend to, you know, conventionally speaking, when you write a function on the page, there's a reason why people are kind of more liberal with it, because the idea is as long as you create a function on the page, you can use it almost anywhere else on the page. Gabriella, is that good?
Yeah, no, I understand the concept. That's not a problem. I actually just have a general question
Sure.
about it for real life. So when you're running, say, a web page, does JavaScript say if I refresh something or I rerun the program, does it have to do it twice again, even if the code hasn't been edited? Or is it just the first time that it has to run twice, and then after that, it's only a one-time deal?
Yeah, so basically whenever you run JavaScript, it always runs it twice. It always scans through the document first, and then it executes the commands. So even if you're on REPL or CodePen, and whenever you click run, it's doing it twice. Like it does it twice in a way that humans cannot control, and that's by design.
Is that is that inefficient ever? If like it's already run through it once and the code hasn't changed, wouldn't it be faster to just run it once? That's all I'm saying.
Um, in terms of efficiency, quite honestly, I don't think it matters that much. Like, I guess theoretically, you could have a hugely like huge file, and usually when we talk about like compiling, like that's kind of where that happens. But the JavaScript engine, especially for what we do, it's incredibly fast, and it's not really an issue. Yeah. So functionally, like from a performance standpoint, it's not anything that you would ever need to be concerned about unless, and I can't even think of an example in which it would be an issue. Hoisting is just so, hoisting is more of just almost like a convenience thing to know that, like, hey, certain things on this page we recognize as kind of like needs to exist in order to prevent errors from happening elsewhere, right? So it's almost a matter of convenience. Because JavaScript could very well just break on this thing and say, hey, will this work hasn't been defined yet. But the way JavaScript works, it says, hey, I'm going to go through, create all the scopes first, create all the functions first, and then I'll do the things you asked me to do.
I see.
Yep. And then and then the other thing to just note is that when I say function declaration, it just means you create a function with the function keyword. If you do something like this is called an expression because you're creating a variable called will this work. When JavaScript reads this, then what this will do is it'll actually create the will this work variable first, not give it a value, and then by the time you invoke on line 4, all right, so on line 6, what gets hoisted to the top is not the function, it's just an acknowledgement that will this work variable exists. And then on line 4, when you try to invoke it, it will fail because it will say, well, this is a variable. I know it exists. The current value is undefined. And you can't invoke undefined. It's not a function. And so when you try invoking it, this will fail. And so this is also another reason why you see function declarations as a lot more popular. It's to leverage the fact that when you hoist it up, it actually, you can actually be more flexible in how you use it. Their question? Here's some wrestling.
So you're allowed to assign functions to variables?
Yep, totally.
Okay.
This is, yeah. And when we talk about objects, you'll actually we'll kind of make note of the fact that like actually everything in JavaScript is an object. It's just like a variable and a value. And so yeah, you can totally store functions in this way too. Okay, scope best practices. Essentially, within the context of a function, so when you think about like why we use functions to start with, there's two main reasons. One is to say, it actually breaks down a pretty complex problem usually into like smaller, more easily digestible bits, and that's like a logic help. The other reason why is because every function is supposed to be in theory self-sustaining, which means everything that function needs to run should be inside that function. Otherwise, you pass it in as a parameter, in which case it is still inside the function. What we're saying here is on line 5 there, right, is I know on line 2 there's a global variable, and yes, on line 5 you technically have access to it, but you don't want to ever be changing variables that have not been explicitly given to you. And the reason why is because on line 8, if someone, oh sorry, on line 10 then, if someone tries to use that variable, it actually may not be clear to someone else that, hey, another person changed that global variable, right? So on inside don't mind me, if you need to read the value of always true, feel free to read it. Don't change it. If you want to change it, then create another variable that's a copy of it and change that, right? Because it's almost like having like a public facing thing. And if one person changes it and the public isn't aware, well, when the public tries using it, then it's gonna break. And so that's what we see here, which also leads to kind of another rule here. So this is what we do here. Now what you do in line 5 is you actually create your own version of always true, and you set it equal to whatever it is that you want. And now whatever you do inside lines 4 through 6 will not impact the global variable, so everything's good. Um, and in and in general, people try to avoid using global variables to start with because the idea is very few things are just needs to be on a global scope. And actually, a lot of things, especially things like passwords and login and kind of personally sensitive information, you don't want that to be accessible everywhere. In fact, you want to be super restrictive about where those are accessible, and so that's where scope also helps in terms of, as a best practice, is it provides an additional layer of security. And that's pretty much it for scope. So as promised, if I go back to the very beginning, assuming this doesn't crash on me. Okay, here, remember this slide here? This I heard of why, like, hey, why does wait for it become undefined? It's because when we go through hoisting, on the first run through, JavaScript just says, oh, hey, I see a variable called wait for it. I know it exists. I don't care what it is just yet. I'm going to hoist it up to the top. And then the console log on line 5 actually runs on the second run through. On the second run through, it says, oh, great, wait for it. I see it exists. What's the value? It's undefined. We don't know what it is yet. Okay, great. It goes to line 7. It assigns the here I am value to wait for it. And on line 9, when it prints out again, now the value is kind of fully rendered. It's fully computed. And we print out here I am. So a lot of times when you see undefined, it just means, hey, you created something, but you haven't given it an initial value yet. So there's a chat here, and then I will open up to questions, and then we will break for lunch. Oh yeah, Gabriella, do you have another question?
Yeah, would you mind scrolling all the way down to like the third or fourth to last slide?
This one?
Maybe after that.
After that.
Or, well, no, actually, no, you're right. Though 19. Everything is broken. Is that an actual error that JavaScript will give you?
No. So this new error keyword, notice how this is capitalized. So error is a class, and whatever string you pass into error, that's what JavaScript's gonna throw back at you. Usually those messages are more for other people. It's like if I'm a human and I write a code and I say, hey, if someone does this and you get an error here, this is why. Like those are meant for humans to read. But the error class does throw up something called an error, that actually just basically kills every code that runs after it. It stops the function then and there.
Got it.
So error is real. That string is something that we've passed in.
Okay. I have one other question.
Yeah, go ahead.
So when it comes to scope, when you had a global variable and then you made, so here, right here, where you have on line 2, you have let always true equal to, or set to true.
Yep.
And then on line 5, because you didn't use the let, it actually reset it. But adding the let kind of had, in a different scope, made it so that it's technically a different variable.
Yep. So right now, on line 5, when I try to change always true, JavaScript will say, great, do you have a version of a local version of always true? As in, do you have a version that's created between lines 4 through 6? And the answer is no. And it's like, okay, great. So do your parents have one? And your parents, in this case, is the global scope. And we'll say, yeah, on line 2, there's a variable called always true. And so on line 5, that's what we use, the global version of always true. On the following slide, when I say, hey, let's create a new variable called always true, well, in that case, I'm just creating a brand new thing, right? And that thing on line 5 has no correlation to the thing on line 2 because I'm basically changing like something that I just created myself from scratch that also only exists within lines 4 through 6.
Okay, so as long as it's declared within the scope, I'm just like thinking
Yep.
to make sure all my wheels are running right. So as long as it's put within the scope, the JavaScript is not going to go to the global scope within the block. So as long as even if it's line 2 and line 5 have basically the same variable without the same value, but because it's declared physically on line 5, then the JavaScript is not going to go anywhere outside to get confused with line 2.
Yep, yeah. Remember we talked about how JavaScript has a particular sequence that it looks in?
Yeah.
It always looks in the local scope first. If it finds it, it stops. Right? If it doesn't find it, then it goes to its parent. If it finds there, then it stops. And it goes all the way. And the global scope is always going to be the very last place that it looks.
Awesome. Thank you.
Yep. Great questions. Anyone else?
David, are we going to review any of the questions from yesterday?
Uh,
The last workshop or functions?
Not as a group, no. Although I guess I could do like an optional review related to that if people want to.
It would be helpful for me at least to look over the most